Hi everyone, welcome to Concept Engine. I hope you all are doing good. In this video, we'll be talking about the second and the third law of thermodynamics. Before we go on to the second and the third law, we need to understand one more terminology related to thermodynamics, and it is called as entropy. Now, entropy in simple terms is basically defined as a degree of disorderness. Now, to understand this, let us consider a domain A. Now, in this domain, all these microscopic elements which are represented by this arrow are in a particular orientation, or they follow a particular fashion of orientation. Now, if we heat this domain or if we stir these molecules, then a particular order of disorderness will be induced in these molecules, and these molecules will now exhibit this random orientation. Thus, we can say that the degree of disorderness, or in other words, the entropy of this domain A has increased. Now, just like time is always moving in one direction, it is a generalized statement that the entropy of the entire universe is always increasing. But in some cases, the entropy of the system can decrease because the system is only a particular part of the universe. But when this occurs, the entropy of the surrounding increases in a greater magnitude. Thus, if we combine the entropy of the system and the surrounding, we get that the entropy of system plus surrounding, which constitutes the entire universe, is always increasing. Now this takes us to the second law of thermodynamics. Now what this law states is that heat transfer can spontaneously occur only from a higher temperature body to a low temperature body. But if you want to accomplish heat transfer from a low temperature body to high temperature body, then we have to generate or we have to provide some external work. Now in this example, this blue color body is low temperature and this red color body is high temperature. Now if you want to transfer heat from low temperature body to high temperature body, we have to produce some, or we have to give some external work to this entire system. Now to understand this, we can take a simple example of a hot bath of water in which we place this ice. Now what we will see is that heat transfer occurs from hot water to the ice, resulting in the melting of ice eventually. However, we will never see heat transfer occurring from ice to water, resulting in the reduced temperature of ice and increase in the temperature of water. This explains as the second law of thermodynamics. Now this system is analogous to a fluid mechanics system, wherein we have a reservoir at higher altitude A and a reservoir B at a lower altitude. Now, the fluid will always flow from high altitude reservoir to low altitude reservoir. The reservoir A is analogous to a hot body, then the reservoir B is analogous to a cold body, with the fluid representing the heat transfer. However, if you want to pump the fluid from the reservoir B to reservoir A, we have to give some external work which will be provided by the pump. Next, we have the third law of thermodynamics. Now what this law states is that the lowest possible temperature which can be attained by any body is minus 273.15 degrees Celsius. Now at this state, there is no thermal motion even at the microscopic level. So going back to entropy, we can say that at this moment the entropy of the system is zero. This state occurs at absolute zero temperature, which we have used as a reference to define the SI unit of temperature, Kelvin, and at minus 273.15 degrees Celsius we get 0 Kelvin. So that was it. I hope you liked this video.
So like, share, and for more such videos, don't forget to hit the subscribe button.
Thank you.